There are a couple key concepts to take away from this question here. So when we're looking at it and we're trying to solve to find the solution or solutions, we notice that you have this square root, right? And we could take this entire function, set it equal to 0, we could graph it, but it's also beneficial to be aware of the fact that if I were solving it by hand, when I'm trying to get x by itself, I would first get rid of the square root by squaring both sides. And the square and square root would just cancel, and I'm left with what we call the radicand, so the part under the radical. Now, if I go to factor this, looking for two numbers that multiply to 4 and add to 4, it's going to be 2 and 2. And the only way to multiply to get a positive, really, it could be either both positive or both negative, but the fact that this is a negative means they're both negative. So anything times itself is the same as saying squared. And the reason I'm writing that is going to become apparent in just a moment when I show it on Desmos. But if you set each of these quantities equal to 0, you're going to get x equals 2 twice. But we just call that a double root. In other words, it means it's the same solution twice. So that's why they say, what is the solution? Singular. It's just this one solution. The answer is 2. But let me show you graphically what happened here. So if I go into Desmos, notice if I type this in, let me go over here. If I type this in exactly as I see it, I could type SQRT to do a square root. I'll do X, shift 6 to do the caret, and then just type this in exactly how I see it. Notice we have this absolute value function. If I set it equal to 0, notice I have nothing. So it seems kind of strange, right? It is until you notice what's going on here. So let me remove the equal 0, and keep in mind that if I write it like this, it's really like I'm saying equals y. Y is a synonym for, let's say, f of x. Now, when you're trying to find a solution, what you're really doing is you're trying to find the x-intercepts. And x-intercepts always occur when y is 0. So that's why this is equal to 0 there. So just looking at this, this is really saying, oh, find the x-intercepts. So when we look here, notice the only x-intercept is 2. If I remove the square root, this will help us see something even better. So this is the parabola, and I could put equals 0, and I'll still see the one solution of x equals 2. But if I just look at it like this, notice this parabola's vertex is at 2, 0, just as it was when we had it in the square root before and it turned into an absolute value function. And because of the fact that we saw this concept of having a multiplicity of 2, whenever you have an even multiplicity, in other words, an even exponent outside of a quantity, that means that that particular solution is going to occur as a vertex on the x-axis. And so in cases like those, it's going to make it so that you can't see it if you set it equal to 0 in certain situations. So just to play it safe, it's better to just write the function and just look at the x-intercepts, or to set up another function, y equals 0, and just see where they intersect, which is the same thing as just finding the x-intercepts. Regardless, our answer is 2.